Outcome 3, Component 1, Part 2 is all about the zeros of polynomials. What we're going to do is start with a matching activity where we're going to take words from this word bank and match them to their statement or their visual representation as well as their definition. I'm going to go a little bit out of order here and start with a few that I think you guys already know. Okay, the first one I'm going to look at is x-intercept. X-intercepts always have to be written as ordered pairs or a point. So my x-intercept in this case would be 5, 0. The x-intercept is where the graph of a polynomial crosses the x-axis. It's written as a point. We saw this back in outcome 1. The other one I think that we might remember is factors. Factors are always written in parentheses, so like this. Factors are an expression that multiplies to a larger polynomial, always written in parentheses with a variable and a number. Giveaway that you're looking at a factor are those parentheses. The next three that we have are solution, zero, and root. Now we have looked at solutions before. Solutions are always written as x equals. And the big idea with solutions is that we find solutions when our equation or our function was equal to 0. So this last one here will be a solution. Okay, zero and root, these are two kind of newer words. Roots are very similar to solutions. They are written as x equals. So I'm going to label this first one as a root. And zeros are still numbers that represent where the graph crosses the x-axis. The only difference, hopefully you notice here, is that it does not have an x equals. If you're asked to find a zero, you will just write it as a number. Now, all of these words here all talk about where the graph crosses the x-axis. So they're all referring to the same part of your graph. The only difference is the way that they are written. So you want to make sure you know if it's an x-intercept, I write it as an ordered pair. If it's a factor, I write it in parentheses. If it's the solutions, it's x equals, and so on. Let's apply this to a few questions. Okay, number 1 says, what are the zeros of f of x equals x plus 4 and x minus 7? Now, using the chart from above, I know that when I go to write my zeros, I'm just going to write the number. Now, this looks like it's in factored form. It has just 2 parentheses. So to find the zeros, I'm going to take each set of parentheses, set them equal to 0. This is my zero product property. To move the positive 4 over, I will subtract. And to move the negative 7 over, I will add. So my zeros for this problem would be negative 4 and 7. Number 2 says the graph of function g crosses the x-axis at 2, 0. So this is my x-intercept. Again, I know it's an x-intercept because it's written as an ordered pair. My question is, what must be a root of the equation? Using our chart from above, I know that roots are written as x equals, and they actually already tell me the answer by giving me the x-intercept. They say the x value is 2, so my root should be 2. Go ahead and pause your video and try number 3. On number 3, they gave us the zeros. They told me they were negative 1 and 3. And it looks like everything they have here is in factored form, so this is kind of the opposite of number 1. The big idea here is to make sure that once you put them into our factors, they are opposite. So this negative 1 should become a positive 1, and this positive 3 should become a negative 3. Okay, next up we have zeros and multiplicities. A zero is where the graph crosses the x-axis. And this is another new word, multiplicity. A multiplicity is the number of times a zero occurs. Okay, so example 2 says, let's solve this polynomial. It gives me x minus 1 and x minus 4 squared. Now, x minus 4 squared really means that this x minus 4 is happening twice. So I'm going to write out 2 sets of parentheses. I'm going to leave the x minus 1 and be equals to 0. Now, if I want to figure out what x is equal to, I could set each of these parentheses equal to 0 and solve for x. So I'm adding the 1 over, I get x equals 1. Adding the 4 gives me x equals 4. And again, x equals 4. Notice that my answers have the opposite sign of what was in the factor. So minus 1 became a positive 1. Minus 4 became a positive 4. Okay, in general, the x minus 4 occurred 2 times in factored form. It had an exponent of 2, showing me it occurred twice. So we could say that 4 has a multiplicity of 2. Okay, multiplicities are always looking at exponents. Okay, a 0 with a multiplicity of 2 is sometimes called a double 0 or a double root. It just has a special name with that multiplicity of 2. Okay, number 4 says, which 0 of f of x equals x minus 3, x minus 1 cubed has a multiplicity of 3? Well, multiplicity of 3 means that I should be looking for an exponent of 3, which I'm noticing right here with that x minus 1. I'm going to use a little shortcut here that we saw in the last one. I know if I set that x minus 1 equals to 0, my answer is going to be the opposite sign, so it's going to be x equals 1. Now it does want me to write this as a 0. Using that chart from the very beginning, I know that zeros are written as just numbers, so my answer would be 1. Go ahead and pause your video to try number 5. Number 5 says, which 0 of g of x equals x plus 1 cubed 2x plus 1 to the second is a double 0? Double 0 means we're looking for an exponent of 2. Now this one's a little bit trickier because it has that 2x minus 1. So to find your 0, you may have set it equal to 0 and solved. I'm going to subtract the 1 over. And then lastly, divide by 2. So I get negative 1/2. And again, it's asking me to write this as a 0. So that means I write it as just the number, no x's. All right, number 6 says, write a polynomial equation in factored form with zeros at 2, 1/3, and has at least one multiplicity of 3. So I'm writing my own equation, and factored form means that I need to have a bunch of parentheses. So here's kind of a form of what we're going to end up with. It should be y equals, and then we'll have our parentheses. It's giving me the zeros, or where it crosses the x-axis, so you might be able to just plug them in. The 2 isn't too tricky. I know that when I'm going into my factor, it needs to be opposite, so I would make this a minus 2. But I personally think the 1/3 is a little bit trickier. So off to the side, I'm going to write that as x equals 1/3. Now, we don't like that this is a fraction, so to get rid of it, I'm going to multiply each side by 3. On the left, that gives me 3x. On the right, these 3's cancel out, leaving me with 1. From here, I'll subtract the 1 over. 3x and 1 are not like terms, so I would leave it as 3x minus 1, and this is now equal to 0. So I could go ahead and plug in 3x minus 1 into my parentheses. Now so far, it does look like my answer is in factored form. I know I have zeros or answers at 2 and 1/3. But it says that I need to have at least one multiplicity of 3. Remember that multiplicity means exponents, so I need to have one exponent be a 3. I'm going to make my last one be a 3. You could have a 3 here with the x minus 2. Either option would be fine. In the last few examples, we're still going to be working with polynomials and trying to find their zeros. The only difference is we're going to have to do a little bit more work to get this into factored form. So if you can remember all the way back to component 1 and outcome 2, we solved the quadratic equation by factoring. Factoring is typically where we have our blanks that are multiplying to some number and adding to some number. After I had it in factored form, which were those parentheses, we applied the zero product property to find the solutions. We're going to do something very, very similar here. So the example 3 gives me x cubed minus 2x squared minus 15x equals 0. Now whenever we are factoring, the very first thing we want to do is look for a GCF. Now number-wise, I see 1, -2, and -15. I don't think that there's any number I can divide by, but I am noticing they all have an x in common. So I'm going to go ahead and take out an x. That GCF of x will hang out on the outside. X cubed means I have 3 x's. I took one away, so I'm now left with x squared. X squared becomes just a minus 2x. And this last part should just be minus 15. Now I think I'm getting a little bit closer to factored form because I now have parentheses, but I do want to go one step further and actually factor what's inside of these parentheses here. So there are 3 terms, so I'm going to write out my blank times blank and blank plus blank. This factoring by grouping is my second step. To find what we multiply to, we're going to take our a value, which is a 1, multiply by c, so I get -15. I'm trying to add to the middle value of -2. The two numbers that multiply to -15 and add to -2 should be -5 and +3. Okay, from here I'm going to leave my first term. I'm going to split the middle term using these two numbers, and my last term is staying the same. I now have 4 terms, which is nice because I can do a little bit of grouping. Now we're looking for a GCF in this first group between an x squared and a minus 5x. They both have an x in common, so I'm going to take that x out. I'm left with x and minus 5. Between a 3x and a 15, they can both be divided by 3. Since I took out a +3, I'm going to put a +3 on the outside there. 3x divided by 3 is x. -15 divided by 3 gives me a -5. Now I know that I did this factoring correct because I see both of them have x minus 5. And the other factor I get from combining the two outside pieces, so x plus 3. Don't forget to drop down this original GCF of x. Now I do want to point out here that my a value was 1. Anytime that a value is 1, we can use a little bit of a shortcut. The two numbers that we came up with were -5 and 3. Look at our factors. We have -5 and +3. So we could skip this middle piece here where we're factoring by grouping, and once you have those values, just plug in x minus 5 and x plus 3. Now that everything is factored, we want to find the solutions. So we're going to take each piece of our factored form and set it equal to 0. Don't skip this x out front. If I take that x and set it equal to 0, There's nothing to add or subtract, so one of my answers is just 0. X minus 5, if I set that equal to 0 and solve, I'm going to get positive 5, just the opposite sign, so that negative becomes positive. And the x plus 3 will become opposite, so it will give me x equals negative 3. Now these are solutions, so they're written as x equals. The next question wants me to write them as x-intercepts. Remember, x-intercepts are always written as an ordered pair where the y value is 0. So x equals 0 will become 0, 0. X equals 5 will become 5, 0. And x equals negative 3 becomes negative 3, 0. These ordered pairs are my x-intercepts. But notice they are the same x values as we had for solutions. Go ahead and take a minute to try number 7 on your own. Here is my work for number 7. Go ahead and take a minute to check if you got that answer wrong. I did use the shortcut here, so once I found the two numbers that multiplied to negative 12 and added to negative 1 to be negative 4 and 3, I just jumped right into those parentheses, x minus 4 and x plus 3. One thing to watch out for, make sure you're writing your final answer as ordered pairs because this did ask for x-intercepts. Let's go ahead and do one more problem here, number 8. This says, what are the zeros of x to the 4th minus 2x cubed minus 8x squared equals 0? And we also want to list their multiplicities. I'm going to start with looking for a GCF. Now I'm noticing they all have an x in common, and I actually think they each have at least 2 x's. This guy has 4, 3, and 2. So instead of just taking out an x, I'm going to take out x squared. Now that GCF hangs out on the outside, we'll think about what's left over. If I had 4 x's and I took 2 away, I'm now left with 2. I had 3 x's and I took away 2, so I'm left with just 1. And 2 x's, I took away 2, so I'm left with no x's, just the x minus 8. From here, we'll factor inside of these parentheses. So I'm looking for two numbers that multiply to negative 8, add to negative 2. Those two numbers should be negative 4 and positive 2. Again, I do have an a value of 1, so I'm going to use that shortcut again and jump right to x minus 4 and x plus 2, using just those two numbers we came up with. I still have a GCF of x squared, so I'll leave that out front. Now that I'm fully factored, we can go ahead and find our zeros. If I were to take x squared and set it equal to 0, to get x alone, I would just have to square root each side, so I would still get x equals 0. X minus 4 is going to become the opposite sign, so it's x is positive 4, and x plus 2 becomes negative 2. The last thing we want to do here is look for multiplicities. That means that I am looking at the exponent of each piece when it was in factored form. Now when I got x equals 0, that came from this x squared. The exponent was a 2, so this one will have a multiplicity of 2. That was for my x equals 0. To find x equals 4, this came from my x minus 4. There's no exponent here, so it's a nice little invisible 1, which means that this one has a multiplicity of 1. And then my last one came from x plus 2. Again, that has a nice little invisible exponent of 1, so this guy also has a multiplicity of 1.